I am going to talk about containers. That's probably not a surprise to the majority of you. And so I have a talk today that we're going to focus on. Can you hear me? Everything look good? And you can see the deck?
Yeah, it's all there. Thank you.
Cool. I'm running on one monitor, so all I can see is the presentation that y'all are seeing.
Yep.
So something
We're
pops
good.
up, just interrupt me, please. Cool.
Yep.
So let's talk about deploying SQL Server in containers. So today we're going to focus on performance concepts. So I'm Anthony Nocentino. I'm a consultant and trainer and founder of Nocentino Systems, where I specialize in system architecture and performance. And I talk a lot about things like containers and Kubernetes and things like that. All right, so let's skip that. We're going to go through some pretty cool topics today in a pretty compressed timeline in the next 9 minutes. And so we're going to talk a couple things about deploying multiple SQL Server containers on individual hosts, right? So the idea is I want to deploy lots of containers. So what are the things that I have to think about when I want to deploy multiple containers on a single host, right? And so what that's going to lead us to is performance concepts, because we want to make sure that those containers are all kind of playing nice together when they're sharing the underlying resources of that physical host or virtual machine that we deploy multiple SQL Server containers on. So the idea is we're going to be able, really want to look at running multi-instance scenarios of SQL Server, which is inside of a container, which is really just SQL Server on Linux. And so that's really what we're going to focus on today. So when we're talking about SQL Server on Linux, it doesn't support named instances like you would in a Windows-based installation where I can have multiple named instances on an individual host. And so what we can do is we can use containers when running a SQL Server on Linux to provide similar functionality. And so if I have a single physical or virtual machine and I want to deploy a container on top of that, well, we can do that with containers and have multiple versions, or not multiple versions. Well, you could have multiple versions. Let's just say multiple instances running on that individual host. And so here you can see I have a SQL Server container that's up and running, and then another one and another one. And what we need to do to deploy multiple containers of SQL Server on an individual host is we need to deploy them with some unique things, specifically a unique container name. So on the right there, you can see SQL 1, SQL 2, SQL 3. We also have to have unique storage. So we see I have attached Docker data volumes, SQL data 1, SQL data 2, SQL data 3, and unique network ports. So there we see 314. I should just choose easier port numbers, but 31, 443, 444, 445, and so on. And so the idea is they're completely unique instances of SQL Server running on an individual host, just having unique names, ports, and storage. But this is the key thing that we're going to talk about today, resource management, because in this scenario, resource management is your responsibility, because we want to make sure that everyone's kind of playing nice in the sandbox when it comes to consuming the resources of that underlying physical or virtual machine. And so let's dive into some container-based performance concepts. So we just touched on this point, resource management being your responsibility. It's so important. I put it in here twice on purpose, not by mistake, because we're going to share the underlying operating system and its hardware, because that's really all an OS does for you, is gives you access to the hardware. I mean, it does other stuff, but I'm a performance person, so that's what I like to focus on. And so when we're running inside of containers, we do have some resource controls that we can use to assert some control on how containers can consume those underlying resources. And in Linux, because SQL Server containers are in Linux, yes, there are SQL Server containers in Windows, but I have feelings. But on SQL Server on containers on Linux, the thing that the operating system provides to give us the ability to control access to the resources is this thing called a control group, or abbreviated as a C group. And what C groups do, give you the ability to control how the individual processes can consume those OS. Those are surfaced into Docker via some command line parameters. So we can literally say, you know what, I want to control the amount of CPU this container uses, the amount of memory that it uses, the amount of block IO in terms of reads and writes, and also the number of process IDs that are running inside of a container. And so those are the primary things that we're going to want to control when we want to provide access to the underlying resources when we're running multiple containers on an individual host. And so CPU, memory, block IO, process IDs, basically the stuff that an operating system does for you. And so Docker gives us the ability to start a container with those resource constraints in place, or the ability to adjust them after creation, which becomes pretty cool. And we're going to see this inside of a demo when I have a query go crazy and I want to basically put some boundaries around a container and the resources that it's consuming, because the query went crazy and consumed a bunch of the underlying resources and made the entire system sad, which would then bring the other containers down too. Not down, but bring their performance down. So this is a pretty deep topic. We're kind of blazing through it today in the concept of the constraints of a lightning talk. But I do have a link here if you want to dive further into each one of the nuances of the Docker resource constraints that you can put onto a running container. And so when we're talking about resource constraints, it's not just controlling access to the resources, but how the container sees those. So let's kind of dive into that a little bit further. When I want to control CPU, I have a couple ways that I can do that. I can limit access to CPU sets, right? Literally specific CPUs on the underlying system. So I can say, you know what? This container can only access CPUs 0 and 1, or 2 and 3, or whatever sets of processors that are available in the underlying OS. I can assert limits, the amount of CPU that I want to have. So if I don't want to limit it physically to the core, I can say, you know what, you can have access to 2 cores. I don't care which 2 cores, but just 2 cores in total on the underlying system. And then I can have shares, which are basically limits, but only kick in when CPU becomes constrained. Now, what's interesting, when we do create containers and they have CPU sets or CPU limits, SQL Server will always see all of the underlying CPUs. And so what that means is, even if I say just, you know what, you can see 0 and 1, or you can have access only to 2 cores, it's going to see all of the cores in the system, because the scheduler is what affects that control, right? So we'll see all the CPUs, but the kernel scheduler will control access to that. Now, on the other side of the fence, memory limits are going to be controlled by actually asserting that limit. So if I say, you know what, you can only have access to 4 gigs of RAM, it's only going to have access to 4 gigs of RAM. If the underlying system has 8, that's okay. It won't see 8, it'll just see 4. But if I don't put a limit on there, the underlying container will see all of the memory. And so let's dive into a demo and check that out. We're going to define a container with some limits. Then we're going to see how SQL Server sees that underlying hardware, how I just described it, can still see all of the cores, even though I have limits in place. And we're going to use a tool called Docker Stats so we can monitor the performance of our containers. And so let's go ahead and do just that. Lots of windows. Which one's the right one? There we go. How are we doing in font size? Does that look good to everybody? You go one notch bigger. Awesome. Yeah, I even tested my demos before I got on to make sure they work.
Wonderful.
So let's not focus on.
So you know.
Perfect. Let's not focus on the code so much, but the concepts, and I'll make the code available to you all to run after the fact. So what we're going to do first here is start a container with Docker run. And there are a couple things I do want to point out. I'm going to give it a unique name. So there we see SQL Demo 1 and a unique port. So I'm publishing access to this container on port 31433. Again, I should use easier port numbers. All right. Now, my buddy Andrew Prusky gave me this fantastic line of code, Docker container ls, and all it's going to do is just give me a nicer output of the containers that are currently running on this host. SQL Demo 1, running a 2019 container. It's been up for a few seconds. It's listening on all IPs, and then the port we defined, 31433. Now, if I go and I ask SQL Server, hey, how much memory and CPU do you see from the underlying OS? It's going to see 2 cores and 6 gigs of RAM. Okay, I have no limits or anything on this container. It should see all of the cores, and it should see all of the memory. So let's do a free -m, which is going to ask the underlying OS for the amount of memory available. So this VM has 8 gigs of RAM, and SQL Server only sees 6. Due to the architecture of SQL Pal, by default, a SQL Server on Linux implementation will only see 80%. So here we see that math right here, 80% of the RAM. And so 80% of 8 gigabytes is approximately 6 gigs. And that's what we're seeing right here, integer math. And so that's kind of the first thing that we have to think about when we're sizing containers on SQL Server on Linux is SQL Pal, right? We only see a subset of the memory, and that's due to the architecture of SQL Pal. If I do Docker Stats, there we can see our running container, SQL Demo 1. It sees all of the memory. Even though the SQL Server process only sees 6 gigs, the container is able to see all of the memory. The amount of memory consumed, the overall percentage of the system, network IO, and block IO. Cool. Let's start another container. This time I am going to have some limits in place. We're going to limit memory to 4 gigs and limit CPUs to 1. That's not a CPU set, just a limit to one total core accessible by this container. Which core, it doesn't matter. If I do Docker container ls again, we see both containers are up and running. Unique names, right? That's what we need. Unique ports, 31434 this time instead of 31433. If I ask that container how much memory it sees and how much CPU it sees all of the cores as described earlier. It's going to see all of the cores even though it limits to one, and it sees only 3 gigs of RAM or 80% of 4 gigs because 4 gigs is all we gave it access to. So let's start a workload. Let me get another SSH session going here. SSHAN at Docker 0. Get this workload going. Content containers. Next. Demo 3. Bang, bang, bang. All right, workload's up and running. Let's do a Docker stats now. There we can see the workload running against our system using about 16 gigs or 16% of the CPU. That should use more CPU. That should be floating around 80, 90%. I don't know why it's exactly reporting that low a CPU. Now, if I jump back, break out of here, let me just open another one. SSHAN at Docker 0. So even though for SQL Demo 2, I have it limited to one core, it's like I said, it should be using about 50% CPU right now. It's not. And so this part of the demo is going to be less interesting when I reduce it to just half a core. And we go back and we'll see it's using about half a core. And I go even further to a tenth of a core. And it should go down to 1%, but it is not. So something is amiss here. But what I did want to call out there, we'll look back at Docker stats here, is that we're able to assert some control on the running container after the fact. So if I start this crazy workload that should have consumed all of the available CPU inside of the individual container, and in this case it didn't, I can come back later at runtime and say, you know what, change Docker update SQL Demo 2 to have only access to half or a tenth. So if a query is going crazy and you can't kill the workload, this will protect the underlying system. The important concept here, though, when we're running containers on Linux is, if I look at a process listing, each one of these containers is just a process running on the base OS. And so the tools and techniques that we're used to using for controlling and monitoring system level access are the same, right? It's just that the isolation principles of containers give us a little bit more control of what's going on inside of that container. So let's go ahead and knock those containers off and jump back over to the presentation. And so we looked at how to create a container using limits, how to examine how SQL Server sees the underlying hardware. We saw that memory is a little bit unique because of SQL PAL, 80%, and it also limits access to the amount of memory exposed. And then how we can use, or how SQL Server sees the memory, or excuse me, the CPU inside of the running process. It'll always have access to all of the cores, regardless of the CPU configuration you assert. It's the scheduler's responsibility to control access to those cores. And we looked at the tool Docker Stats to help us monitor performance and see which containers potentially going a little bit crazy. But in the end, it's just a process running on a base OS, and you can also use your other tools to monitor your system. So yeah, that's kind of the big concepts today: deploying multiple SQL Server containers on hosts and some core container performance concepts.